Hello friends, how are you doing? I hope everyone is doing fine. I welcome all to one of the very interesting topics in geotechnical engineering, which is nothing but the three-phase system. In this video, we'll be discussing the basic concepts from the first part of the soil mechanics syllabus, which is the three-phase system, and this is the first part of the soil mechanics syllabus for the GATE 2021 examination. I know many are preparing for the exam and trying to make out the strategies for the same. So without wasting a single minute of time, we shall quickly go into our today's topic and start with it. So what is a three-phase system? So let's consider a soil mass. It consists of solid soil particles, right, with void spaces. So these void spaces will contain air or water or a combination of both. So if void spaces with either water or air alone, it is known as a two-phase system. Why it is called a two-phase system? The void space, if it is filled with water alone, then water and solids will be there in that particular soil. And if it is the void space is consisting of air alone, means it consists of only solid and that air. So only two phases are existing. So it's called a two-phase system. At saturated condition, a soil mass is called what? Three-phase or two-phase? It's called two-phase system. Why? Because it consists of only two states or two phases. One is the solid phase and the other is the liquid phase, soil and the water. So let's consider the total volume of the soil mass. Total volume of the soil mass, we take it as volume of air plus volume of water plus volume of solids. In that we consider volume of air plus volume of water as volume of voids. So we can substitute VV, that is volume of voids, for volume of air plus volume of water. So we get volume, the total volume is equal to VV by VS. I'm sure you are familiar with it, with this annotation, so I have not written it separately. So this is in brief about the three-phase system. So let's go into the properties in detail. So let's first consider the two main properties, void ratio and the porosity. First one is void ratio. What is void ratio? Void ratio is the ratio of total volume of voids to the volume of solids. So we can give an annotation like E for void ratio, and it is equal to VV by VS, which is equal to N by 1 minus N, where N is called the porosity, which we are going to discuss in the next session. On the next point, we are discussing the porosity. So void ratio is the ratio of total volume of voids to the volume of solids. VV by VS, which is equal to N by 1 minus N. These are very important formulas. Why? Because in GATE exam, it can be asked as 1 mark question or as 2 marks numerical question also. Next is porosity. Porosity is the ratio of the total volume of voids to the total volume of soil. So void ratio we saw total volume of voids to the total volume of solids. Now porosity is the total volume of voids to the entire volume or the total volume of soil. So we give the annotation for porosity as N, which is equal to VV by V, which is equal to E by 1 plus E. Very important formula. Please remember it. Next is degree of saturation and air content. So let's discuss degree of saturation first, which is the ratio of volume of water to the volume of voids. So saturated soil mass means it consists of water, or it's like sometimes it's partially saturated, sometimes it's fully saturated. So degree of saturation means the actual content of water which is present in a particular soil mass. So how we find it? It is equal to volume of water to the volume of voids, like how much water is there in the voids. That is what for fully saturated soil mass. What is the saturated degree of saturation? It is 1. Why it's coming 1 for fully saturated soil mass? Because volume of water and volume of voids will be equal. It will be completely filled with water. So SR is equal to 1 for fully saturated soil mass and 0 for perfectly dry soil mass. Why? Because in a perfectly dry soil mass, the volume of water will be nil. So we can take it as 0. The degree of saturation will be 0. Next is air content. Air content is the ratio of the volume of air to the volume of voids. Like the same like degree of saturation only. In the degree of saturation we saw it is the content of water in the voids, but in the air content it is the air in that particular voids. So it's a ratio of volume of air to the volume of voids, and the annotation for air content is AC, which is equal to VA by VV, which is equal to 1 minus degree of saturation, that is SR. Next comes the percentage air voids. What is percentage air voids? It is different from air content. Don't confuse it with the air content. It is the ratio of volume of air to the total volume of the soil. Air content is represented as AC, whereas percentage air voids is represented as NA. NA is equal to VA by V into 100. VA is the volume of air and V is the total volume of the soil. Next comes the water content. Water content is the ratio of weight of water to the weight of dry soil solids in a given soil sample. So we can represent it as W. So W is equal to weight of water, which is represented as WW, by WS, which is weight of dry soil solids, into 100. Next is a very important topic. Why? Because there are so many functional relationships which depends on these densities. Like there are different types of densities, like bulk density, dry density, then the density of solids, then saturated density of the soil mass, then the submerged density of the soil mass. So all these densities, definitions and formulas we should remember. Why? Because we have to use it in the functional relationship, which we will discuss in our later sessions. So let's discuss the density. The first type of density, which is the bulk density. Bulk density is the total weight of soil mass to the total volume. So it is represented as W by V, which is a very simple relationship, and I have represented it as Y for density. I know generally it's represented as gamma. You can do the same thing, no problem. Next is dry density. So from the name itself, it's pretty much clear, right? So dry density, it's a weight of the soil solids divided by the total volume. So YD is equal to WD divided by V. Next is the density of solids. Density of solids, it's a weight of soil solids divided by volume of the solids. So this dry density and density of solids, don't confuse. Density of solids, we are taking particularly the case of the solids in the soil solids. So it is a weight of soil solids divided by volume of solids, whereas dry density is the weight of soil solids to the total volume of the soil. So the density of solids, YS, is equal to WD divided by total volume of solids, which is VS. So two more types of densities are there. One is saturated density of soil mass, which is the total weight of a fully saturated soil mass to the total volume. So Y saturated is equal to W saturated by V. So we have to take the total weight of a fully saturated soil mass. Fully saturated soil mass in the sense it completely consists of water. It's completely saturated to the total volume. So W saturated by V. And the last type of density is submerged density of soil mass. So we have to take from the name itself, we can remember easily. It's the submerged weight of the soil solids or the buoyant unit weight to the total volume. So Y submerged or gamma submerged equal to WWD submerged divided by V. And mathematically we can represent Y submerged is equal to Y saturated minus YW. So these are the different types of density of soil. So the soil will be under different conditions. Sometimes it will be dry, sometimes it will be saturated, sometimes it will be submerged. So in different conditions the density of soil varies. So please remember these formulas, and in the next session, this was part 1 for the three-phase system. In the next session or in the next video for the part 2, three-phase part 2, we will be discussing about the specific gravity of the soil solids, the formula for that, and in that itself apparent specific gravity is coming, and functional relationships, which is very important with respect to the GATE exam. Many questions can be asked from that particular session. So those things we'll be discussing in our next part, that is three-phase system part 2. So thanks a lot guys for listening, for the points I have shared. I request you to share your comments and the clarifications, whatever clarification you want you can request for that, and just tell me what kind of you'll be expecting on the videos, on what all topics you'll be expecting. So mainly I'll be posting videos on all the topics from our syllabus, the GATE syllabus, from the civil engineering one by one, and with the previous year papers, like previous year questions as well as solutions also. So you can subscribe and turn on the notifications so that you will be getting my videos on time. You won't be missing any of my videos. Also, please share with your friends, like whom you think this will be helpful. And also this the points I'll be sharing, I know these are not in detail, but I just want to give you the concepts from the topics of the syllabus. I don't want to describe it in detail, and I don't want to waste much time also. This is actually helpful for those who have already completed it, or who are preparing it, or who just want to brush up, and for everyone this will be very much helpful. So thanks for the support, friends. So I see you in the next video. Thanks a lot.